meeting on the two
Yeah,
phone also coming. Okay, we wait that just a moment here. I do like that. Okay. So then, so
yeah,
maybe you have
yeah, we
you
can
have the
start.
floor. Yeah. Okay. Hello, Mr. Natufo. Nice to see you.
Yes, nice to see you.
So let's start. We have 3 minutes wait, and I have a full program. Um, I don't want to overstretch too much then with the time. Then let's go forward. So Rumo, maybe you
Yeah,
introduce us.
yeah. Greetings, everyone. I welcome you all to IVETA webinar on new trend in TVET. And the idea of this webinar is to bring stakeholders together to see how we can improve TVET globally, which is in line with IVETA vision. And due to the challenges of climate change and sustainability, I think it is crucial for us to empower our youth with critical skills in the area of green energy or renewable energy. So that is why we brought Mike Dietrich to take us through green skills for green job. And the idea is to empower youth globally. Welcome, Michael Dietrich. Over to you.
Thank you, Sarumo, for the short introduction. Hello to everyone. Sarumo, can I ask you that when someone come in that you allowed, yeah, and give them entrance to our presentation? So I have, of course, prepared something for all of you today. It is a nice presentation, a pretty presentation about topics. The topics of our webinar today is green energy training for green collar jobs. And I would like to give you an introduction about green energy technology and sustainable technology, especially on an example of real example in Europe, because it is a home area. But of course, we have many other examples around the world, and also have sent the direction link how Lexler covers this technology with training products for the especially for the TVET sector. So, and special thanks, of course, to you, Sarumo, that you organize this meeting and invite your colleagues to be there, and your friends, and also members of IVETA. And for us, as a global company, it's an honor to be here and present you this presentation. And I hope we have some interesting facts for you today. Just short information, who is Lexler? Lexler is a specialist company. Just a moment, I make also my watch here. It's a special company established in 2003 as a spin-off of University in Dresden. And we are now around 22 years in the market. And I would like to say we are one of the leader, or the leader for hands-on skill development training systems in the world, with around now 16 countries what we cover with around 50 partners. Immediately, I would like give in a second slide the biggest motivation why we do what we are doing. So, and that is the reason that new energy it's one technology globally who not destroy jobs, like for example automatization or robotic or AI. We will see new energy already create jobs globally. And that is for us a very good motivation to work for that. and use it as a business case for our company. Here we have some numbers, as we have around 16 million globally jobs now already there. Of course, most of jobs in the solar photovoltaic. In the production or manufacturing of solar module, of course, China is one of the biggest source, but other countries growing rapidly, especially for installation power and maintenance. You need a significant number of very educated people, what we can handle then with our training equipment. What is interesting, liquid and biofuels, that is the second biggest source of jobs globally with more than 2.5–3 million people. The reason is that is a point in a lot of ethanol production, especially in Brazil, and that is the reason why we have so much jobs there. We expect up to, let's say, maybe 40 million jobs up to 2030 around the world. And what I mentioned before, it will be especially also an area outside the manufacturing, typical manufacturing countries like in Asia, China, or in Europe, maybe Germany. It will be in the countries where we install the new energy sources. In the global energy sector, we have 135 million people around, and then you can see the significant impact of new energy technology in a global demand of well-educated people. So, just short words about the different also major streams what we want to handle with our products. As we also work in the school and STEM level, but mostly important, the big demand is in the TVET sector, the technical vocation education training. That's mean from vocational school up to college, university, and also industry sector. It's our customers. And here you have an overview about some references what we already have in our list. Some major brands from the energy sector here in Germany, for example, E.ON or NBW are major suppliers of energy in the world. From the new energy sector, Goldwind are one of the major manufacturers from wind turbines. It's our partner. We are partner of them. That is more correct, and support them with our products to educate staff, but also maintenance people. And for sure, usually education institutes are our main users. It's our main customer group. So what I mentioned, like vocational schools, high schools, and colleges. Here, a short example of one of our leading projects in Malawi. Before Corona, already that was around 15 vocational schools what was equipped by us, but also for other topics, for electric engineering, civil engineering, automotive engineering, and we handle special the part of electric engineering for the new energy sector. And just now you see here the students working with training system for smart grids in this moment. And that was really nice and successful project. Other project is in Senegal 3 years ago. That was electrification of rural area with around 200 villages was equipped with solar power stations, and then also need then Zoom X of cases to train the people there that they know how to handle the solar power stations in a daily business. But let's go to the different technology. The general presentation is that I give you a little bit overview about the different new energy topics. that you have imagine maybe sometimes also some new facts what you don't know before, and then in the second step of each technology I would like then give you an overview about the products, how we cover this technology. So of course photovoltaic, how produce solar power, electricity with solar power, and we have here just a moment. We have here an overview about solar technology, and up to now we have efficiency rate of up to 50% with special technology in solar cells. In a daily business, solar cells have just now an efficiency rate between 22 and 25%. That is around 2 times more, or more than 2 times more as what I already have when we start our company 20 years ago. Then it was around between 12 and 40%, and you can see that is a significant development in the last 20 years. Up to now, crystalline technologies, mono or multicrystalline, are the major technology what is already in the market. We have some technology like thin film technologies that is then especially some manufacturers from US market, but mostly all the most of the solar technology what is installed and what will be installed in the next years, it's based on lithium technology. We have here in Dresden, that is my hometown in Germany, some specialist manufacturer who produce organic solar cells, what you can cover windows of big buildings, of skyscraper, etc., and use then also these possibilities of spaces to produce electricity with this kind of technology. But that is have not at the moment a significant impact when you compare it with the installed power in the lithium or with other solar cell technology. Applications, everybody know we have, I would like say, I'm not sure, maybe 40, 50 years or more, around 50 years already solar application in the market. First one was with space, with satellite technology, calculator, everybody know, and now more and more we see solar installation all over the world. Germany, it's one of the major markets, or was one of the major markets in Europe, but now Spain and others are following. We have now around 140, 150 gigawatt installed photovoltaic capacity in Europe, and that you have a little bit more and better imagine what means as 100 gigawatts. That is around 30 big coal power plant what already replaced by photovoltaic power in Europe. And what I mentioned, Germany was one of the biggest, was one of the countries with the biggest installed capacity. Here with in the north of Germany, in Brandenburg, it's a solar park with 166 megawatts. It is not so much, of course, when you compare with other installation projects around the world. But what I mentioned before, we have here examples, especially from Europe. I'm not use any examples from China in this case, because usually we will find there a lot of large-scale projects in the new energy sector. So how we looking on how we want to train photovoltaic in a market for the students that we have after this training, a well-educated and trained person. We address with this product electrical engineering and want to make here basics of solar energy. We explain different kind of solar cells. We explain what is the difference between a cell and a module. Explains the different, just a moment, the different components of a solar system, that we have a lot of electronic components. And you see just now here on this picture also the possibilities what we have, that we have not only a black box like for big treating systems, that you have an AC/DC inverter, but you don't know what are the different electronic components in an AC/DC inverter. And here this small part are the different main components, what is integrated in an AC/DC inverter to explain different features and how you use in a real application system. I go one step back. We also offer a curriculum for each product, or let's say we offer a curriculum proposal, because usually each customer, especially in a vocational training, have an own imagine and an own idea how to integrate this kind of topic in the actual curricula. For this reason, we decide that we not propose ready-to-use curricula. We propose to give a curricula proposal, and then the skill development agencies or also the university have then the possibility to think how to use our content and integrate, for example, in a course for bachelor level of electric installation. So I go forward. Then for information for each product, I also add some experiments like that you have and imagine how it works, the components working together. Now here a very important experiment that is already done. We here, just a moment, I go here forward. We investigate here how solar module working. In this case, we have around 3 solar cells who simulate a solar module connected in a series connection, and then we can see what will be happen when you cover one of them. We lost a lot of energy, as that is from what you usually think that you have maybe 30% reduction of power, but we lost maybe 90%. For this reason, you integrate, we call it a Schottky diode. And with this Schottky diode, you also can then bridging this solar module what is covered, and you have only then 30% reduction of power. Another sample experiment, and usually we have maybe possibility to make around 30 experiments with the whole system. And here with this one, you see we have a different connection of, just a moment, I need to be, first one we have solar module working immediately with consumer modules, then we integrate an storage system and capacitor. The capacitor need an electronic regulator who regulate in which power we integrate the solar power to the capacitor, and finally then complete solar system is also integrated in deep discharge protection module. This module is important that you have not the risk that your battery in a real case you have lead acid battery or lithium polymer batteries is not discharged, and you have a problem that the battery is destroyed and you not can use it and can store energy. Okay, so the other technology what is very close connected to the sun power, it's thermal energy. Thermal energy, it means then use the sun power and produce heat, or in this case is then with solar concentrate power with mirrors. Yeah, you see here the sun brings heat to the solar mirrors, and then the concentrate solar power coming to a turbine and produce also electricity. Also here an example from the real world. You see when you compare with photovoltaic, it's a significant less of installing power. Only 4 coal power plants are replaced by solar thermal energy technology. And one of the major projects is one project in Spain, in Andalusia, with 150 megawatts, with solar mirrors around there, and then they produce or bring the turbine here in the center and producing already electricity. What are the main learning content? It's thermodynamics, fundamental thermodynamics, heat absorption of different materials. We explain different solar thermal technologies, how working in a heat pump and storage solution. Yeah, that's going here. You see the component. Yeah, how working a warm water collector in a small size. We have a parabolic reflector. Also, we explain how working and let's call it a storage system for heat. We can compare different materials, and paraffin, for example, is one of the best options to store heat already. So let me go a bit forward to coming here also to the experiment with the warm water collector. Now we have, I go a bit forward. Yeah, we already install an water pump. We have our one water collector with this power module. We regulate the artificial sun, and then we can see how the collector, the warm water, or the water in a warm water collector will be growing the heat, and you can using the heat pump already. So from solar power, we're coming to the oldest technology, hydropower. Everybody of you, I'm sure you have a hydropower plant in your country, maybe in a micro size, maybe in a large size. In any case, hydropower is already a significant source in Europe. It generates 36% of renewable energy sources. And we have here a short overview about the biggest installed capacity in Europe already. Interesting that Norway, or especially in general, the Scandinavian countries have a lot of resources for in hydropower. But also what is interesting that in Turkey, you have a lot of hydropower plants. That was for me a new fact. But you can see it is already a limit. When you see the top countries for 2019 of new installed power of hydropower plants, it is only 200 megawatts or 130 megawatts in Norway. When you compare with already 30,000, 32,000 installed capacity megawatt in Norway. That means it's a limited space or a limited capacity that you can install new capacities in hydropower, and then also the option to use it as backup power system. It's not so much possibilities because of limited resources like river or good places to use it. Example from the reality, here in this case from Sweden, with the big hydropower plant in Sweden close to the Lula River, with a capacity of 1 megawatt and annual production of around 2000 gigawatt hours. So how we try to bring this topic in a small box. Usually you have at the moment in the market only 2 options. You have big options like manufacturers, like let's say from Spain, maybe also from India or from China, from Germany for sure. And in the fundamentals, usually a small system, what working only like a demonstration system for the teacher, where you cannot share any activities. We try to bring this in a box to change the different configuration, like for diameters. That gives the possibilities to change how much water flow you have, and of course we integrate also different hydropower water turbines, Pelton turbine, cross-flow turbine, and traditional water turbine. Integrate different manometers. Also have an special induction generator to measure to produce electricity. So I have also one experiment here. Just a moment. There you see the two ladies already set up the system. We use different components from the industry. So I go a bit forward that we're not watching the whole video. Yeah, we decide just now to use the Pelton turbine because they have the highest efficiency. We already install the induction generator, and now we open the valves and the water is going to the turbine with 7 liters, you see. And voila, we have already electricity. Now, in that sense, the main task for the student to understand which kind of, what is the best design, which turbine technology working well, and also how much water pressure you need for your hydropower plant to have a significant output of electricity. So water power, wind energy are a little bit also sister technology, both of them using plates and turbines. Yeah, and that is then the reason why coming to the next part. And we see wind energy is one of the biggest sources of new energy already in Europe, I think also globally. When we coming to the biggest manufacturers, just now, also in this slide, it's Vestas and Siemens Gamesa, but in the last 5 years, I know that Goldwind is now one of the major suppliers for windmill turbines. Also from manufacturers and other manufacturers in China and also India, now in the top 10 list, but already in the top 10 for sure Siemens Gamesa with production utilities in Germany and Spain, GE, and yeah, for sure Vestas is up to now one of the major companies for wind turbines around the world. And that is interesting for our guests from UK. Yeah, UK, Great Britain want to be already one of the mega hubs for installed wind power in Europe. Yeah, and make a significant shift from oil and gas production from the North Sea up to an electricity manufacturer based by wind power in Europe. And of course the reason is you have a lot of coastlines in UK and also a lot of wind. So how we want to we cover these products in our with our products. We have the main learning content here is to understand optimal design of windmill turbines. We not simulate it with electric machines. That is another possibilities how you can use that. And to give you a short overview, we have here some significant modules of a wind system with a wind turbine, different rotor sets, a wind machine, what is a very high efficiency wind machine with 6 meters per second, and give you possibilities to have a very nice and concrete wind direction. also different kind of rotor technologies, and Savonius rotors integrate, and different measuring instruments. So what we want to say, yeah, okay, let's do like this experiment. We have in this experiment, just a moment, I already go a bit forward, back. We compare here to a traditional windmill with optimized plates within Savonius rotor. And it's working like you see, we have up to 3, 4, 5, 6 volt. So not bad. That is how windmill is working. Maybe the pitch angle is also optimized with 25%, something like that. And now we change the technology. We move to the Savonius rotor, and you see it's a significant different. So maximum only 0.5, 6, maybe 1 or 4, 0.4 voltage. Not more, but what is the reason why we use Savonius rotors? Because they have a very fast starting speed, as the wind speed not so much high to have already output, and that is the reason why I use this technology like on the top of buildings, on a roof, or also in the maritime industry. So also we have a second video, same, we can make around maybe 25 experiments with the system, and the second I would like go deeper in the influence of different pitch angle, but we have a little bit limited of time and much more topics what we want to talk about. So that is then this part. Now we're coming more in the area. This area was more electric engineering based. Now let's come to topics what is close, have also a connection to electric engineering, but also a connection to chemistry engineering. Of course, also connection to the automotive area, because fuel cells, it's not, it's also a potential technology what we want to use for cars. But of course, just now it's look like that electric engines or the electric battery technology, it's absolutely in a major leading position, and that is then not so easy for the hydrogen to be in a car sector and significant technology. But for backup power systems, and we want to really make a move to a CO2-free economy, then hydrogen solution, it's it's a key factor to do that. Here an example from France and refueling station, I think Total already, and France have also significant investment in this area and have also a lot of buses on the road already, but compare with traditional engines or with electric engines, it's of course very less. Some words we have, of course, hydrogen have no color, but with the color we give the hydrogen or identify the hydrogen from which sources he is made. Green hydrogen, that is what we all of us want to have, but globally we only produce 0.5 up to 1% of global hydrogen production is based on green hydrogen at the moment. Most of them is gray hydrogen or blue hydrogen. We have that's mean not made with new energies. We have also violet hydrogen that is made with nuclear power, or brown and black hydrogen with coal or oil and gas. Just a moment. So, and that is then the reason how you produce it. How much hydrogen it will be made in 10 or 20 years based on green energy. As a global outlook, it's between 10 and 20%, but you can imagine that is an absolutely a lot of significant growing capacity what we need to install globally. It is up when I'm around the world. There's a major investment around the world in this technology. We will see what will be happen. Usually plans are made and then maybe not exactly will be happen what people expect, but we see just now but electric cars. I would like to talk later. We're coming to this part. So how we cover this topic? We have one box in the TVET sector, or we have three, but here in this training we want to talk about one. We cover also different parts. Want to explain hydrogen, how you produce in a PEM fuel cell technology, have different experiments, can make a green hydrogen production with an electrolyzer, and also see capacity and possibilities of an fuel cell stack. So let me go a bit faster to electric vehicles, the efficiency of electric vehicles. One information, also that is an actual slide of forecast of sales volume for electric vehicles or plug-in hybrids around the world, and we have around 22 million. The global market capacity of car production is around 100 to 120 million globally. That means 20%, 25% already electric cars. That is when we start with this product in 2018 or 2017, we not expect that it will be so massive growing. Of course, one of the reasons is the big rush in China that they move her car industry now 50% of the production there, it's already electric cars. And we see already this pressure in the global market that they bring her cars all over the world. In Europe, yeah, one of the major markets is Norway. That is usually, it's in one case very interesting because Norway is in the north and not the optimized country to use electric cars because it is very cold in the winter time. But they have, of course, a large capacity to produce electricity, and that's it's one of the reasons why they are also globally up to now the leading country with electric cars measured by EVs per capita. So here's of course the reason Norway have not much people, but a lot of electric cars on the road. And China have a lot of people and maybe only. It is of course not really only. It is around just now. Let me think. 50 million around at electric cars on the roads there. How we cover this topic? We concentrate with our product a major part of an electric car, and that is the battery, the most important part, and we want to investigate which kind of battery technology are important to use. What is the advantage and disadvantage when you load and you disload the different battery technology? And that is also compare with a fuel cell, understands advantage and disadvantage. At the one what I mentioned, fuel cell, it's a very expensive technology when you compare with the already battery technology what is using in the market. We also investigate in traditional lead acid battery, LiFePO, also very new technology, and have also a small mobile to explain the technology and have a nice experiment. What I want to show you with the second one, just a moment, not the first one. Yeah, the second one here. So as we have, we use three technologies. Now we use three different batteries: lead acid battery, a lithium polymer battery, and a nickel zinc battery. And now we want to make a short competition, which battery has the longest distance or the biggest acceleration. And then that was a lot of rounds. Now we use the lithium polymer battery. And count the rounds and the speed. And last is then an capacitor would have a very short charging time, but of course a very limited resources. So yeah, in result we see the lead acid battery has the biggest capacity, the longest range of distance, but also the longest time to reload. And only up to, as we have up to round 10, and yeah, then other parts here. So now we come, I would like say, to the highest complicated discipline when we talk about new energies. And that is why I mean say like that, because we see, especially in Europe just now, in Germany especially, we see now also what you need to think about also. Not only to install and make great capacities of new energies like photovoltaic or wind energy, you need also in the same side, in the same level, you need to think about transport capacity and management and storage of the electricity, to have not, for example, the reason or the risk of blackouts in a system. And here a short, what is the electric grid in Europe? You have the major suppliers of hydropower in the north. You have the potential south countries to produce a lot of solar power in the south. You have possibilities for wind power here already. This area with UK, Denmark, and the North Sea for wind energy, and mostly you have the consumer, the industry sector in the center of Europe. Usually, is that it's an optimal case? Yeah, that you have not the biggest consumers somewhere on the border of the continent. We have it here in the center. Of course, that is the optimal case. That is the grid what we want to have in Europe. We will see how long time we need to establish that. You see, maybe for 2 weeks ago, we have already a blackout in Spain, and the reason was an overload of the power plants. Too much PV power was available, and then the net cannot use it. And then we have already a blackout because the grid was already overloaded. Of course, we don't want to overload the grid, but we want to give the engineers a vision and an explanation how and what you need to care about when you have a lot of new energy sources in a public grid. You compare, so that is one of the topic, comparing conventional grid with smart grids, thinking about how you can handle the grid stability in a radial distribution system, and the grid stability based on renewable energies, how you control and measure that, and how you can integrate, for example, backup power, for example, with electric mobility, fuel cell, and so on. So you see, we have then a lot of modules and also big possibilities to make. Let me switch to the second experiment that it's a bit better. Secure stability based on with PV power. You see, we also use then two base units because we need all these places to make complex measurings. We have already, and here on the top you see a conventional power grid. We measure already with a smart meter how much electricity it's produced, coming with transport line to the private household. And we have second line, a big power plant here with our solar module. We simulate different timelines. We also can simulate different angles. And then the same line, the electricity coming here from this consumer module to transforming line and here. And we have from the back side, from the consumer side, we also produce electricity, but bringing electricity back from the grid, from the consumer side. And that is one of the challenges, how you can manage a grid when you have not only a central manufacturing hub of electricity based on a conventional power plant, for example, nuclear, oil, gas, and so on, but also thousands of households producing electricity, and you need to manage then the grid stability when all these households bring in the same time electricity with the public grid. Now, and that is some of the task and experience what the students have to do. It's, I think, as one of the complex systems, and also when what I can say, when we use small components, it's a significant engineering level what you want to cover is this topic. Now, in the last 2 products or 3 products, we're going more in an area, let's call it agriculture 3.0. And what is then more connected to biology and sustainable technology. Biofuel production, it's a topic. So in biofuel production, what means that? We have biofuel, also ethanol production. Usually we drink it in Europe with wine or with beer. We have a consumption of 12,000 million bottles of wine in a year. Interesting. As I drink more beer, of course, I am from Germany. So one of the major production of biofuel is Poland. It's for me also interesting, but I have heard about that they have a significant private production of alcohol. Maybe that is the reason. But how you can use it in an experimental system. So the key features here are that you want to understand at first how you make an understanding of the fermentation process, understand how you make within distillation, how you produce ethanol. So here, that was the point. Also alcohol fermentation, distillation production of bioethanol with creating of mash. You can use different ingredients like potato, wheat, corn, whatever. And then in the distillation process, you already produce an ethanol, and you can use this ethanol in an Mr. Natufo, can you please switch off your microphone? Thank you. So, And then also you see in a production how you can use this in a different parts. Here it's an distillation. We have a cooling system. The important thing is here make an experiment also in 45 minutes, as a produce ethanol in 45 minutes, and use then also an ethanol fuel cell that the student has then a complete circle of ethanol production and how you can use this ethanol already in an in an engine and produce electricity finally. And second product, it's bioenergy. Bioenergy in Europe, yeah, also bioenergy, it's mean different parts like pellets from wooden, or also biomass production with urban farming and vertical farming. And we handle this product. We have a product, we call it bioenergy with two options. Or not two options, that it's two major topics. One of the major topics, how you produce biomass with the artificial nutrification, with the correct illumination with lamps. And second part is how is the reduction. Also how you can reduce the biomass also. Also what is the way, the compostation with chemical process you have already with compostation, and which kind of energy you can use, like methane production, and then use this methane already. So as a main learning content here, the complete biomass cycle of production and reduction, to make it short. So I don't want to explain, let me a bit faster here, so not to show you each part. So first experiment, then you have from the beginning, you have the little seeds growing with lamps. It's of course an experiment, what is depend of the seeds what you are use, and needs then time from let's say 3 to 8 weeks, depend of the time of the ingredient what you use. And then also the major topic, second one, is then compostation, and how you can use this part of methane already and have already also an energy output from the biomass reduction. Yeah. So last but not least, coming to the biggest resources of new energy technology. And the biggest resources globally is not new energy resources like photovoltaic or wind power or something like that. The biggest resources is energy efficiency. Of course, well, energy efficiency is not so much a topic, for example, in Nigeria. When you see like here, capita CO2 emissions per capita, or India, it is more a problem of the Western world. Especially America. I think the Europeans not so bad, but the biggest consumers CO2 consumers per capita already US, KSA, or the Middle East region, and that was interesting, Kazakhstan and Australia for sure. So, and that is then something what is also an interesting topic what we handle. We have in Europe or globally already this analysis of products, what is from G level up to A plus level for the different efficiency of the different consumer products. And just in Germany was a special project, we call it 50-50 project, that students in schools already identify what are the wasting consumers, like heat, like electricity, or something for CO2 in a building, analyze it, and find then possibilities to reduce it. Yeah, like, and that is then oh, just a moment, sorry. That is then a system with a different energy measuring instrument with a concrete manual only, also because only to use this technical instruments, what is available in a market, you need also a concrete pedagogical material, what gives the student a guideline how to use it in a project and understand what they have to do. So, well, finally, I'm coming to the end. I'm totally in time. Thank you for your attention. Just a moment, how I can teilen and beenden. So maybe you can open your camera, all of you. Yeah, we have not so much participants. That will be nice.
Yeah, thank you.
So,
Thank you. Thank you, Michael, for your presentation. And I think it is a robust presentation. And with the recording of this presentation, we can actually share with some of our members, because I want you to throw more light on the skills youth can actually possess from these green skills, the identified skills, and also how this training can be transferred to developing nations and to Africa, how we can train teachers and how we can empower youths with these green skills. And it will be good for you to identify the areas, like for example plumbing. For example, you identify plumbing, but now in green skills you need to identify the areas. It will be technicians that can produce this green skills equipment, or technicians that can installation of this green skills equipment. So we want to know the areas where we can empower our youth on green energy. Thank you.
yeah, thank you also. As that is the point what I mentioned before. How you see here, the products are not only video gaming. Yeah, that is a real experiment to give basic engineering understanding of the technology. And when you're talking about a plumber, of course, you need to know something, for example, of pumping systems, and also maybe for thermal energy systems. And solar installation person need to know which kind of components, what I mentioned before, is in a AC/DC inverter, and also back to plumbing engineer, you maybe need to know what is the different turbines for an hydropower plant when you install micro hydrogrids, hydropower plants in the countryside, for example. What is then usually a small technology what is not based on mega scale power plants. It's then maybe only 100 or 200 watt systems for very small rivers in the village area. And then, of course, it's good to know which kind of technology it's easy to use.
Yeah, there's one question from Dr. Julian, who is the immediate past president of IVETA.
Uh-huh.
The question is on the chat box.
Yeah, I see.
Okay.
I want to read. As the question was maybe for everybody of you was how it's training for teachers need to have pedagogical and technology material. Uh, of course, yes, we have already provide teaching material for teachers and for students, and also give a possibility, also a proposal how to integrate in a different activities in a school or university or vocational school. Yeah, because like an electric engineer needs some topics of that. And we also, that is our motivation, we not want to offer complete bachelor training courses. We want to offer micro certification or micro credentials for special topics what the students need for this technology, because they one automotive engineer, automotive specialist, he need to know the different battery technology. He maybe not need to know how working a bioenergy system. A farmer from the farmer area, an agriculture specialist, he need to know more important facts for bioenergy production, or for example biofuel production. Maybe also pumping system, yeah, what I have in the solar thermal collection. That is different specification of experience what we already cover. And that is then also then connected to the major topics what you already want to train in the different TVET areas, also TVET sectors of countries. When I see maybe demand in southern countries for electric engineers or electric specialists, we don't want to call it electric engineers. Engineers each time maybe a master engineer, but you need based. Also I don't want to say you need. I want to say I think you need. It's of course it's a feedback what I got from usually activities. More basic and training activities for skill development. That is also, as we not offer research activities. For research activities, other manufacturers in a global market maybe offer much more systems that you can do research much more better. But when you want to have an entrance door to open and find some information for the different technologies, then we immediately put the students from the school level and brings them to the first, second, and maybe also third step in the vocational level. And the last three step, maybe when you have go to step 6, and it's then to working with the realistic system based on what you can find in the market already.
Thank you, Michael.
Yeah.
Naomi, you can unmute your mic.
You have a question, Naomi. Hello.
Okay, yeah, thank you very much, Michael. A very interesting presentation, and
Thank
I
you.
think with some immediate usefulness, I should say, because I think that well, TVET institutions train broad topics. Where these ones, which you are saying micro credentials, can provide someone with like an end product, not just a broad topic. For example, electrical engineering, or maybe at TVET level, but somebody is able to produce an end product, like this is how you come up with an electric car, this is how you come up with a biomass bioenergy system. And for me, I see, if I look at the situation of Southern Africa and the needs of the masses, see, for example, the issue of biofuels, bioenergy, and even electric cars, not looking at electric cars as vehicles to drive as on the road, like passenger vehicles, but as a mobility issue, which can be used even beyond just cars. So I think you can even give these, let's say, for students who are doing, let's say, a 2-year course, they could round up with 1 or 2 of these as micro credentials, and therefore walk out with their 2-year course, but with quite some good expertise on something. This is how I see it. And thank you very much for the presentation.
Thank you for your words.
Thank you, Naomi.
Great. Some other questions? Maybe also the information what we also see from the manufacturing side. Yeah, of course. I would like say we are in education is our business. That's mean, of course, we want to make money with our products. But what I want to say is that really working from the basic level. We have then the possibility to be connected with any advanced system what you can buy in a market when you want to use it. Like, also let's you have two maybe customer cases. One case you're going only in a basic level, yeah, that they understand the technology, and then working immediately as a professional in the labor market and with the products what you already use in the market, like a plumber has then other equipment like a solar installation or an automotive specialist, a mechatronic specialist. But also when you're thinking like in a university level or on a college level, then we are each time maybe it's the first step in the first or second or third semester, and then you can immediately integrate other products like bigger products what we have in the market. As we have great manufacturers in Germany, we have also great manufacturers in UK. I would like say maybe Matrix is one of them. And we have also, of course, also great local manufacturers. What I see in South Africa already, some companies who produce training equipment with local, also with components from the local markets, as a real, real industry components. So, but that is then usually that is also a little bit the challenge what we have already with our products. You have not a mass production, but you have also not a case by case production. Like in a big system, it's usually case by case. So in the big systems then gives then each time the engineering levels, the ready to use engineering level. But before we see each other in the position to make the first training, and especially on the safe side that you not care about which kind of power we use, because always with 12 voltage, maybe later 24, but not more. That's mean on the safety side, and that is also important from the pre-knowledge of your students. That you don't need to care about that what can be happen. Because, and that is not a point in Africa, it is a globally problem, the pre-knowledge of the students, as the pre-knowledge level of the student globally is another level, let's say like 20 or 30 years before. So, and we're starting all over the world. That is in Germany, it's the same maybe point. Also, when we have, of course, a big tradition of engineering education, that is students coming from the high school level, and you need to start again with basic training activities. What is a circuit? What is a series connection? What is a parallel connection? What is an electrical circuit? Whatever, to pick them up from this level and bring all of them in a same level that you can continue and have not a very different education or training level, what gives you then a very hard challenge that finally you have a professional level of each student who are ready for the labor market.
Yeah, thank you, Mike. I just want to ask this question: if you have special training programs for teachers to be equipped with these green skills so that they can teach or train their students.
I understood you mean that we can make trainer programs.
Yeah,
that's a key question now.
Yeah, training programs for teachers.
Yeah, we do that. Sure, of course, it is usually connected to our products. As what I mentioned before, we not give a complete consultancy for curricular design. What a plumber need to know, it's maybe 100%, and we cover with our products, let's say 20% for the basic training activities. For this kind of activities, we already offer training program with training specialists, what we have located in some different areas globally. And but it's all connected with our hardware. So and that we can do it online or also in a face-to-face training activities like this project in Malawi already was one example where we have done an activity. Last year we have 3 trainings. One was Malaysia, other one was in Dubai, and of course Europe. It's also daily business. But usually we offer this activity just now in English, German, Spanish, and maybe Arabic. Also French language, that's for some African destinations, is maybe for us a challenge, but we can handle it. Let's say like that. Okay, we have 2 other questions.
Mr. Martin, you can unmute your mic.
Yeah, all I was going to say was just to kind of help pacify people. I've used this kit. So I'm an electronics engineer. I've got no chemical engineering background whatsoever. It is supplied with, I think, really comprehensive teaching notes so that's from your teacher training is supplied with the worksheets for your students. I spent a week with it and I'm really confident that I can use this kit. So it's really intuitive. It's quite easy to use. So I wouldn't worry too much about the teacher skills not being currently in the market. It's definitely something you can pick up. It's very hands-on. I'm no expert now, but I could definitely use the kit. So I wouldn't worry about if you feel you have a skill shortage in territory. If you've got an engineering background, you can pick this equipment up. It's just the way it's designed. It's very clever. That's all I want to do. Thanks.
Thank you,
Martin. Anthony, you can unmute your mic.
I have just a moment. I have only some additional information. And that is, that is maybe for you important also to know. We coming, of course, a little bit from the education tradition from the German side. Yeah, it is not a secret. We have also good friends in the UK, and they help us also to integrate the product and the curriculum experience of us in a UK standardization. What's a little bit in other directions than the German style of training. So, and that is then helpful in many different regions worldwide. What is more adapted to the curricular design like in UK. So, and then only want to add, and that then maybe also helpful in your destinations to use like that. Sorry, Anthony.
Anthony, unmute your mic.
Good evening.
Hello, Anthony.
Mr. Mike, I want to thank you for this opportunity. I love the presentation, and as a matter of fact, it resonates with my interest.
Thank you.
I would like to ask, how can we youths benefit from this opportunity? Because I run an environmental sustainability non-governmental organization, and these are one of the areas that are of importance to me, and seeing how we can drive the green transition by helping young people, equipping them with green skills. So I would like to also thank the executive director for IVETA organization for such initiative, for partnering with your organization. And we would want to see how youths, young persons that are in Nigeria can benefit from this opportunity to upskill them, in this regard. Thank you.
Thank you, Anthony.
Maybe any question for you, Sir Romo? That you can...
What he's saying, how can youths from developing nations like Nigeria benefit from training in green skills? So we are looking at a position where we can organize training to empower maybe the trainers. The trainers will not train the youths in Nigeria, because it is not possible for us to train 50 persons at a time, but we can train the trainers, like few persons with engineering background or with interest in green energy. So those persons that will train will not train the youth back home in Nigeria. So what he's saying, being that he runs a non-profit organization in Nigeria and is into this renewable energy, and they are working for climate change and the transition. So what he's saying is looking at an opportunity where your organization can train trainers from Nigeria to train youths.
Also I will translate it to an understanding like I understand that it's not means that I understand it correct. But what I mentioned before, we are not a non-profit organization. Yeah.
Yeah.
That is for everybody is clear. But
yes.
what maybe to make an when you're looking for a global impact, what is the opportunity for you to do anything, transition to green skill, anything? For you, it's paid citizen in the future. That is just a moment. That is the opportunity why countries invest in education and in people who have good jobs in this country. And what I mentioned before is that is one of the biggest impact of what green energy offer to any society globally, because this technology that is not, of course, because of Flex laws, that is the reason of new energies that we create. In the new energy sector, we create more jobs or that we kill jobs. So what is the possibility? How? Of course, I don't know I understand the question correctly, but I would like maybe give an outlook. You just a moment, Rumi. It's the possibility. What you have to think is, of course, an impact will be in the market and analyze how much potential capacity maybe we would like have. Let's say in Nigeria, let's say like South Africa, in solid power. You want that, for example, a lot of Chinese specialists coming and make also installation activity of solar cells in your country, make all ready to use, turnkey solution, and then go away from the country. So that you have then the capacities there, and maybe also a nice leasing contract for the next 20 years. And then after that, the infrastructure power plant is yours, or you would like have an X number of educated people who already understand how it works and create own micro business activities. That is similar like what I talked shortly about a project in Senegal. It was based from GIZ, KFW, electrification of landscape areas. That was 200 villages. That is not much, but 200 villages got electricity. So, and they need, of course, also specialists to understand how working this power plant. That was only a one-scale project. We have a major project in a World Bank. They're talking about the 30 million project. So with 30 million, they mean it was 300 million. 300 million projects. 300 million people they want to educate in solar, something about solar power. It's an unbelievably large number. The complete population of USA, they want to educate in solar energy. Of course, it's a difference between what the politics say and what the politics will do. But expect from this number, it's a global trend, and that's mean local production of new energy sources. That's mean local jobs in the destination countries where you have that. So, and the impact, come back to the question of your colleague. The impact is you have then educate people, and educate people have good jobs. Good jobs pay tax for each country. It is an answer a little bit longer, I hope, but I hope I got the key points.
Yeah. And Martin,
Yeah, I can actually add on that, which is more relevant to Nigeria. So your NTBE is just currently developing some new curriculums for renewable energy. So at a NID level and an HND, national diploma level. So I think it is something that's coming to Nigeria, both at the kind of innovation enterprises and also the polytechnic. So there is something at a government level which is starting to bring renewable energy technology into specifically the Nigerian market.
Yeah.
Thanks.
Thank you.
So maybe also when I don't know, it's clear, but maybe we can also open this. Martin is very well educated with our product and also know very well how to integrate in different professions. As not only the new energy sector, when I can say like that, he also know very well to use other professions. And maybe that is then a connection like to have an expert who is available locally.
Yes.
Like not like you said, almost that you're based in the UK most of the time.
Yeah, Mr. Luranti, do you have any question? Okay, and there is this message from Mika. Mika is a member of IVETA and is one of the administrators of a TVET center in Nigeria. So he's asking if you can provide your contact for possible discussion.
Sure. Now I'm available in the LinkedIn for sure. Please contact me per LinkedIn. Just I would like add my just a moment. Yeah, I forgot
you
to
can
make
add the link to the
the
chat
link.
box.
Yeah, just a moment. I forgot to make a QR code in my contacts, but that we can just a moment now. And of course, welcome. Yeah, that will be. I will be happy to have you in my connection. And when questions, please contact me there. That is usually the fastest way. And but I think also for concrete question in a local market, Mr. Martin or Mr. Netufa a good address. So just here, but for here, please, in the chat you have my connection to the LinkedIn profile, and I will be happy to be connected with you.
And Bahati, do you have any question or contribution?
Can you hear me?
Yeah.
Yeah.
Hello. I'm so sorry. Not at this moment. I was having some internet problems, so I just connected. And yeah, so I guess maybe later on we're gonna stay connected after this. Yeah.
Okay. Bahati is the vice president of IVETA Southern Africa. She's from Malawi, and few persons from TVETA Malawi, they joined this session.
Okay. Yeah, pity. Then you maybe not see this example that we have a nice Malawi project 5 years ago already. Yeah, that maybe you heard about it, but was not only with us, that was connecting to many professions in the country. Welcome.
Okay. Mr. Netufo, do you have any question or contribution?
In finished reports because we have not done physical inspection.
So practically we'll close this session, but I want to prepare your mind, Michael, because this presentation is very robust, and it will be good if we have another session of this same presentation so that we can present it to a larger audience, because it is very important, owing to the fact that we are all accepting climate change, and we are trying to see how we can sustain for sustainability sake. So I thank you all for attending this webinar, and it is a good one. Thank you, Martin. I thank you, Naomi from South Africa, Mr. Netufo from Nigeria, Professor G, I think is from India, and other participants. And I also thank the immediate past president, Dr. Julian, for his time and his participation in this event. And we'll share the recording of this webinar to those who are supposed to attend this presentation but could not make it. And thank you so much for your time. Thank you for this wonderful presentation. And we'll keep on the dialogue to advocate for the advancement and improvement of TVET globally, and especially in developing nations. Thank you so much.
Okay, thank you very much, and bye-bye to everywhere.
Thank you. Bye-bye.
Ciao, ciao. See you soon.
Thank you, Michael. Thank you.
Bye-bye, Martin.